All right, we're now into section 2.3, where we're going to start talking about Venn diagrams and what we call set operations. And so we've talked in the last couple of sections all about different sets, subsets, proper subsets, lots of different notation. Hopefully you're starting your 3x5 card and you're writing down all the different notations and what they mean, maybe some extra examples or homework problems, so you can keep it all straight. But in this section, we're going to go ahead and take the set ideas and we're going to draw them visually. Kind of a diagram to help us see how sometimes these sets are related or maybe how they might be different. It's called a Venn diagram. And so in a Venn diagram, we typically have what we call a universal set. And so it's represented with this big old rectangle, and it just helps us show that we're talking about all the different elements under discussion. And so the universal set is used, the shape is a rectangle, and then inside we might have different little circles that are subsets of our universal set. Sometimes those are ovals, other shapes, but typically those are circles that we use to represent subsets. And so if I give you a Venn diagram, for example, number 1, I have a universal set, and we're talking about all of the different elements in this universal set. We have subset A that has the 2 different elements in it, but there are some other elements out here under discussion in our universal set. Excuse me. So in this example, it says to use the Venn diagram to determine each of the following sets. So the first one says U, the universal set. So tell me what elements are in the universal set. What elements are we talking about in this picture? Well, I don't know about you, but I noticed a square, I noticed a triangle, I noticed a money sign, an M, and a 5. So I would say that universal set contains the elements, the square, the triangle, the money sign, the capital M, and the 5. Now, what elements are in set A only? Well, by looking at the picture, I notice that set A contains just the elements that are the square and the triangle. Part C says the set of elements in U that are not in A. So what elements do you see in your picture in the universal set that are not in set A? Well, if I take out set A then, what elements are left? Well, it looks like to me the money sign, the capital M, and the 5. So being able to pick out the little pieces of your Venn diagram. All right, so we showed an example just now of one subset, but there might be 2 different sets inside your universal set. Sometimes they have nothing in common and might be separated like this. Sometimes they might have lots of things in common and look like this, where A is a subset of B. Or maybe more specifically, a proper subset, right? Because they're not the same exact thing. Where here, A is a subset of B and they're the same exact thing. Sometimes only little pieces of the subsets relate or correspond or overlap. I don't know, maybe an example would be set A is a set of all females and set B is a set of people wearing jeans. Well, that would mean their overlap here would be all the women that are wearing jeans. There are some women that aren't wearing jeans, and so you could see where they overlap and maybe where they don't overlap. And so that's another example of using subsets. All right, so now that we have 2 different subsets in our Venn diagram, can we still answer questions about it? Now, this one's kind of tricky. Do you notice that they use Roman numerals? Now, these Roman numerals aren't representing elements in our set. They are representing different regions. And so really the elements are the lowercase letters. And I would just say that region 1 is really talking about this whole region. It's not really adding to the elements of my set. So just be careful with that. Okay, so example number 2, part A, says use the Venn diagram to determine, first of all, the universal set. So what elements are in our universal set? So I would like you to list me all the different elements in our picture. I said A, B, C, D, E, F, and G. Those are all the different elements in my universal set. So now what elements are in set B? Well, if this is set B, what elements do you see in this set? I see elements D and E, don't you? All right, let's keep going. Look at part C. Part C says the set of elements that are in A but are not in B. I want elements that are in A but that are not in B. So I have elements A, B, and C. Do you see it? All right. Try doing D and E. Now that we've done a few together, see if you can list the elements in part D and E. Part D says the set of elements in U, the universal set, that are not in set B. So I don't want any of the elements in set B, but I want all the other ones. And so I said I have elements A, B, C here. And don't we also have F and G in our picture? Don't forget about those guys, even though they're on the outside. All right, part E says the set of elements in both A and B. So looking at our picture, what elements are both in A and in B at the same time? That would be that middle section here. So element D is in both sets A and B. All right, let's do one last example here, adding another different notation to our ideas about sets. We're going to talk about what we call the complement of a set. We use this little symbol here. It kind of looks like a little apostrophe. And what that means is that all the elements that are in our universal set that are not in set A. So when I have that little sign, that little symbol, little complement piece, it means everybody that's not in set A. Okay? So looking at example number 3, I've taken away our picture now, and I've just written out our sets in roster method. So you need to be able to do all of these problems either with or without a picture, because they're going to give it to you a couple of different ways. Looking at example number 3, we have the universal set that contains the elements 1 through 9. So our big rectangle would have all of those numbers in it. Set A would have the numbers 1, 3, 4, and 7. I'm asking you for the complement of A. What elements are in our picture or in our universal set that are not in set A? So I don't want 1, I don't want 3, I don't want 4, and I don't want 7. So I would say that the complement of A, all the elements that are not in A, would be the numbers 2, 5, 6, 8, and 9. The complement of A, all the things that are in our picture that are not in A. Practice those few first concepts before we move on to the next idea in the next video.